of change. Now, average rates of change is pretty much your year 9 gradient formula of y2 minus y1 over x2 minus x1. The idea is when you say average rate of change, this is really all it's saying. If I draw a graph, and I draw it like that, right? There are infinitely many points between a domain. So from A to B, there are infinitely many points. So for example, if I said from A to B, from here to here, okay, there are infinitely many points in between from A to B. And if I ask you for the gradient of the tangent line for every single point, they're all different. So when you say average rate of change, what you're really asking is, what is the rate at which the gradient is changing every time? So y over x, 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 y over x. You can't calculate all that. So what we do is we find the average. So how do you find the average? You say, all right, well, I'll just take this point and that point, and let's just hypothetically say, what is it overall? That's what you normally do, right? You sum all of it, and you divide it by a number of numbers, yeah? And it's the same concept. That's all you're doing here. You're just saying, what's the distance from here to here? What's the distance from here to here? Divide them, find that ratio. And what you're actually doing there is, oh, I can't get my pen. There we go. You're just finding that gradient, which is why it's the vertical distance. So the sum of all the changes vertically and the sum of all the changes horizontally. You're just looking at that ratio there, and that's the gradient, yeah? And then also the average rate of change, meaning whether your y value is changing from y1 to y2, x1 to x2. Okay? We want to know what the changes are. And overall, on average, is it positive? Is it negative? What is it turning to? That's all you're looking at. Okay? So this is called the average rate of change, which is why the questions, when you're answering them, they always give you an interval, and that's always the case when you're doing an exam question. There'll be a difference between finding the average and then finding the average rate. Yeah, instead of finding the gradient, and then that's different. That's differentiating at one point. Yeah, you're trying to find the gradient at one point, whereas average is you're trying to find it over an interval, and usually they'll give you an interval. Yeah, the mistake that most students do is they differentiate it and then sub the intervals in. So, for example, if I said it was between 1 and 3, and they say find the average rate of change for the equation y equals x squared, what a lot of students do in the exam for a multiple choice question is they'll do dy dx, which is the gradient, and then they sub in 1, sub in 3. Okay, so what they're actually doing there is they're finding the gradient when x equals 1 and the gradient when x equals 3. Find the average of that. Now that's different because you're looking at the gradient of this and the gradient of that. You're not finding the gradient of your possible values in between. Okay, so it's y2 minus 1 over x2 minus x1. Okay, but that's pretty much what exercise 10B is about. And you'll find that a lot of the questions will start off pretty easy. You got your y2 minus y1. The only thing that you really got to take out of it that they actually use 10B for is your kinematics. Velocity, displacement, and acceleration is the only one that you have to understand the difference between average and then non-average. So instantaneous and non. Yeah? And that's what this slide is about. It's about average rate of change versus instantaneous rate of change. What's the difference between the two? Average rate of change, gradient between an interval, right? So between 2 points, it's on over an interval, y2 minus y1 over x2 minus x1, right? Whereas instantaneous rate of change is what you've been doing. You're trying to find the gradient of a line at one point. So that's differentiate and substitute. Okay, so that question, if they ask for instantaneous rate, you'll always find that they'll tell you at one point. They'll say when t equals 2, find the instantaneous rate of change. Yeah? But if they say average rate of change, they normally say between 1 and 2, or before 3 seconds, something like that. Okay. Now, if we were to do this example here, okay, so we've got your average rate of change between, you notice it's between, x is between 2 and 3, so you should be thinking y2 minus y1 over x2 minus x1. You've got average rate of change again, and again, 2 and 2 plus h. It's an interval. y2 minus y1 over x2 minus x1. Whereas instantaneous rate of change, they say x equals 2. See, that's only 1 point. So there's always a hint. When you're reading the questions, they tell you what to do. What you're not meant to do is differentiate and then substitute 2 and then substitute 2 plus h. Okay, that'll be incorrect. So if we were to do this question here, whoops. Here we go, A. Want to find the average rate of change. Very simple. And it comes up in the exam quite a bit too. I think it's because students get confused between average rate and then find the derivative. So in this case here, you're literally just trying to find m, which is f of x plus h minus f of x. I'm just writing it as function notation. But remember, this is just your x plus h minus x. Okay, so in other words, I'm saying y2 minus y1 over x2 minus x1. In our case here, we want from 2 to 3. So you got when x equals 2, f of 2 equals, and then you sub 2 in, right? So for A, I'm looking at the question that, oh, I don't know what's going on here. There we go. F of 2, sub 2 into the equation, 2 squared plus 2 times 2, 4 plus 4, you got 8. Okay, so you now know x1, y1 is equal to 8. And now you go to x2, y2. So when x2 equals 3, f of 3 equals to 3 squared plus 2 times 3. That gives you 9 plus 6, 15. Okay, so if you answer this question now, it's simply y2, which is 15, minus y1, which is 8, over x2, which is 3, minus x1, which is 2. That gives you an answer of 15 minus 8 and 3 minus 2. And that gives you what? 7 on 1. So it'll be 7. And depending on what the units are. So when you're doing this for velocity or whatnot, then it'll be like meters per second or distance per second or whatever it is. But in our case, we don't know what the units are. Okay. Does that make sense for average rate of change? Yeah? It'll be the same thing. The only thing that's different over here is you get a parameter that you get 2 plus h in it. Okay, so it's kind of like your first principles. Your first principle is the same idea. Okay? But if you were to do instantaneous rate of change, that's just asking what is the gradient when x equals 2. So to do C would be I am going to find the derivative 2x plus 2, but I want to know at 2 what that equals to. And that happens to give me 6. So the gradient at that point, that's called instantaneous. That's the difference between the two. So one is a rate, talking about an overall. One is a gradient, 1 point. So one's 2 points, one's 1 point. Okay? Now, this is what I want you to learn. Motions in a straight line. For those who do physics, maybe this is a bit more familiar. For those of you who don't, then let's revise and copy the notes, yeah? So motions in a straight line. You've got these two formulas here. Now, when we use x, what does x represent again? You got v, which represents velocity. A represents acceleration. What was x again? Good. What's the difference between displacement? Sometimes they call it position as well. But what's the difference between displacement versus distance? What's the difference between velocity versus speed? What's the difference between the two? Ben? Good. So that by definition makes sense. Well, it's true, but a lot of times we don't understand what that means. So Ben says displacement and velocity are vectors, and they have a direction. So if I were to tell someone right now who hasn't ever learned physics and doesn't know what we mean by direction, give me an example of something to show the difference between displacement and distance. Give me an example. Yeah.
And then the distance would be like what it did, whereas displacement would be the line between where it's all turned.
Fantastic. Absolutely that. If you think of like a racetrack, yes, you're right. a racetrack, if this is the start line and that's also the finish line, then a car would have traveled whatever the distance is for the circuit. That's the distance. But if we're talking about displacement, it's relative to where they started, or the origin is what they call it. So if I started at S and I drove the car all the way around and I landed back at S again, my displacement is 0 because I haven't moved anywhere in terms of positioning. That's why they ask where your position is relative to where you start. Am I, after all this movement, am I left of where I started? Am I exactly the same spot? Am I to the right of where I am? That's why it's more directed about direction. Distance, on the other hand, doesn't matter. Distance is only calculating the value that from the moment you move, how far have you gone? I don't care where you have, relatively where you've gone. I just want to know how far you've walked. Okay? So it's kind of like being lost in the forest. It doesn't matter how far you walk. It's more relative to about your positioning. You want to get out of the forest if you're lost. It doesn't matter how much you've walked. So I've walked 10 Ks, that's great, but where are you? I'm back at the start. There's no point. You want to know that you've gotten out of the forest. So that's displacement. You want to make sure that your position's out of there. It doesn't matter how much distance you've walked. Okay? Now, if that's distance and that's displacement, then that gives you two different types of definitions here. That tells us there's a difference between speed and velocity. So the velocity formula there is talking about you've got the change in displacement over the change in time. So technically I'm saying x2, which is position 2, relative to position 1, and then time 2 minus t1. This is your average rate, yeah? So when I say average velocity, this is talking about your displacement. Whereas speed, what's the formula for speed again? So if this is for velocity, that's what I got up here, dx dt, that's for velocity. What about speed? How do you find out speed? Yeah, but distance, you see, doesn't have like a start. The start point is always 0. So normally what they call it is total distance, how far you've traveled in total, and how long it took you to travel that. So that's why we say total distance, distance, but we write total there, over the time, but we're looking at total time. Okay, so this is speed. And this is important to know the difference because in your SACs, or any exam that has a kinematics question, the only reason why it gets tricky is because they'll ask you to find the average velocity versus the average speed. And they might go one after the other. And a lot of students will get confused because it feels like speed and velocity are the same, 60 kilometers per hour. But there's a difference. Velocity, we're talking about displacement. So where are you position-wise relative to where you were? Whereas speed, you have to calculate the distance. And that's where it's tricky. When you start learning integration, your job is eventually to find out the distance, how far you've traveled in total, and the time. So when did the car start? Because if you're stuck, then you've got 0 velocity, and then or 0 acceleration, and then you move in a different direction. That's where it gets tricky. Okay? But in terms of this exercise, you're not going to do any of that at this point. It's only chapter 10. We haven't gone to integration yet. But that's what you need to know in terms of the difference between the two. Average velocity is this position or displacement, whereas speed is distance. Okay? And then finally, acceleration. Over here, I've got acceleration as a equals dv dt. Acceleration is how fast it takes you to reach a particular speed. Okay, so if you started off at 10 kilometers per hour, you're driving, how long did it take before you get to 60 kilometers per hour? See, like a Formula 1 will get there within 2 seconds, 100 k's per hour will get there in 2 seconds. You get my car, it takes 10 seconds. Okay? That's called the acceleration. How fast can you reach a particular speed? It's what acceleration is. Okay? So same thing again, dv dt would mean that you got v2 minus v1 over t2 minus t1. Okay? How do we feel about those definitions so far? Yeah, difference between displacement and distance. Now, it's about working with the questions. Now, the questions in 10B, the only ones I want you to really try to get your head around is this. Okay? It's just really getting your head around with displacement distance.
For acceleration, for example, for dv and dt, should that
pick the acceleration at a point, but then v2 minus v1, v2 minus v1. Is that average acceleration?
Yes, it will be average acceleration.
They're not the same.
When they say, when they write that formula, it's actually the average acceleration overall. How long it takes, because it's over an interval. Yeah.
But the derivative would be the acceleration at a point. So
yes, the derivative at a point. So if you sub in, so for example, if I gave you an equation for velocity, if I said it was, I don't know, x squared plus, actually it can't be x squared, dv dt, so t squared plus 2t, right? Then that means acceleration would be the derivative of this, which gives you 2t plus 2. Yeah? This will only tell you the average acceleration over whatever the intervals are, but if you want to know the acceleration at a particular point, then you'd say at time equals 1 second, my acceleration is. So that's called an instantaneous rate of change. So that's at one particular point. Whereas overall, 2t plus 2 is the overall. Okay? All right, let's try to do a question now. Let's try this. Here we go. Have a look at this question here. A particle moves along a straight line. So you've got a straight line, particle, you give it a dot, and in a line such that its position, so it now tells you that you're dealing with position displacement, which is x meters, relative to a point O. So there's a point O, you start at this point, and this particle moves in a straight line relative to where the origin is, right? And the time is in t seconds given by the formula. The displacement is equal to, or your position is t cubed, so whatever the time is, cube it minus 6 times t squared plus 9t. The first question says, at what times and in what positions the particle will have zero velocity? So when you read that question, a velocity, you can say that velocity can only be found by finding the rate of change for your displacement. So in my case here, for A, I need V. But to get V, I need to find the derivative. So the derivative of my position on my displacement equation, this is my displacement equation. So the derivative of that is, what's the derivative? T cubed minus 6 t squared plus 9t. Yes, Aaron. Yes, Aaron.
What do you think about it? Seeing as no one else put their hand up, I will take the time and see what happens. Ben?
You're taking too long. I'm going to pass it back to Ben.
3t squared minus 12t.
3t squared minus 12t plus 9. Fantastic. Now this gives you your velocity equation, but the question says at what time? So you're trying to find time and position. So you don't know what x is, you don't know what t is, but you want to know at what times and what positions will you have a velocity of 0. So in this case here, I've got my equation for velocity. When velocity equals 0, I can solve for t. Now notice this is a quadratic equation. You can factorize this. Now I'd take out 3 as a common factor. You get t squared minus 4t plus 3. Factorize that for me. What's t squared minus 4t plus 3 factorized? What does that end up being, Mazen? T squared minus 4t plus 3. Factorize that for me.
T squared minus 4t plus t.
Plus 3.
T minus 2t minus 1.
T minus 3, t minus 1, correct. Okay, now if I were to solve this, what would t, which is the time that we're trying to find when the velocity will equal to 0, what would that be? T equals to what? Should it be? 3 and 1. So what does this imply? So I want you to think, because these questions here are pretty straightforward. I haven't talked about speed at the moment, but when you are required to work out speed, this is when it gets tricky. You see, when t equals 1 and 3, you said velocity equals 0. What does that mean? In this context. What does it mean? Yes, ma'am. It is a stationary point on the graph, but just in terms of the particle, what's happening? Steph?
Going back to its original position.
Not its original position. Particle stops moving. Because velocity equals 0 means that you are no longer moving at all. Okay, so this would be, and it could also mean that coming back to its original position because it's getting 0. But what this actually just tells me is I've just stopped. Particle's moving in a straight line relative to its position, and I'm now stopping. Okay, so velocity being 0 means it stops. Now it stops at 1 and 3. So wherever it's moving, you've got a particle, let's say it starts here, that's at the O, and it moves in a straight line. At some point, it had to have stopped. Okay, and then it moved again for the next 2 seconds and it stopped. Now what I don't know is whether it kept moving forward or whether it moves backwards, because it matters. And the only way to know that is if you're going to find the positioning, because the position tells me how far I am. So let's say this was 5 meters away from the origin, and then I work out, this is at t equals 1 second. And if after 3 seconds, if I end up over here, you should expect the displacement should be, let's say, 8 or something. Then that implies that I've moved an extra 3 across. But then, if the displacement was instead at x equals to 2, then you know you're going backwards. Okay? So that's where it gets tricky to find the average speed, because you now have to work out the distance that is traveled based on its positioning. Okay? But let's just pause there. I've just got t equals 1 and 3. I need to find x as well, because it says what are my positions, right? So let's find out x. How do I find out x now? I've got t equals 1 and 3. How do I find the positions? Yes, Ben? Good. That's my equation. X equals to whatever it is. So I got to sub into the original to find out my position. So at t equals 1, I should have 1 cubed minus 6 times 1 squared plus 9 times 1. And that gives me, what, that's 1 minus 6, negative 5, plus 9, 4. Okay, so that tells me I've got a position of 4 after t equals 1, right? So that means if you draw a picture, I started at the origin. I've moved after 1 second, so when t equals 1, I'm now at 4. Okay, so I'm at position 4. Assuming that positive means going to the right. Okay? I've stopped there. This is when my velocity equals 0. I've stopped. The question is, am I going backwards or am I going to continue on? Right? So I need to now know when t equals to 3, where is my positioning? So I've got 3 cubed minus 6, 3 squared plus 9 times 3. That works out to be 27 minus, what's that? 9, 54 plus 27. What does that work out to be? Oh. What does that imply then? I'm going backwards. Okay, so the only way to get 0, it means that my displacement or position relative to where I started, I went back. I went back to where I started, so that's why I'm at position is 0, t equals 3 seconds. Okay, this is when t equals 0, velocity equals 0 as well. Okay, because we can't assume that, but I just know, actually, I can't assume that. Sometimes because it's moving, we don't know when we'll call the time. But we know time equals 0, position equals 0. And it went after 1 second, position is 4. After another 2 seconds, my position is now back at, this point I've stopped. Okay, so this is when velocity is 0, velocity is 0. So if you were to calculate the speed in this case here, you would have to find the total distance. Now, what would the total distance be in this case? Not 4? 8. Because you walk all the way to this point, 4, and then you walk backwards, 4. Okay, and that's where it gets tricky, because the example that you got here is an easy one. Normally what they do is you move across by, normally it looks like this, starts at an origin, moves across, comes back, and moves back. That's usually the question that they give you, and you've got 3 points. You got stops here, and stops here. So you've got 3 points where it stops, and you have to work out the distance from here to here based on the positioning, and then from here to here, that's your total distance. That's when it gets tricky. Yeah? So those are the kind of questions to expect in an exam, whereas the questions you're getting right now, it's pretty straightforward, just up, down back to the origin. So that comes 4 across, 4 back. But that's the difference when you're finding velocity and speed. This question doesn't have a speed question there, but if it does, that's what you have to pay attention to. Okay? Because the next one's pretty straightforward. It's acceleration at those instants. Find the derivative of your velocity equation, and then sub in 1 and 3 for the acceleration. And then it's velocity when its acceleration is 0, so let A equals 0 solve for t. So those are straightforward. It's the speed that normally students find difficult, difference between speed and velocity. Does that make sense so far though? Position and distance? Yeah. All right, excellent. But that's it. That's exercise 10B, and that concludes chapter 10 on what you need to know.
It's actual
14. Monday 14. It's always a Monday. Monday double session in the hall. 14. But you get a notification tag to tell you. I can't remember which day I've been distributed. You get it. All right, cool. I'll leave it there. And those are the questions. Those are the questions.